All right, lesson 5.2 is about rational equations. So in chapter 3, we dealt with rational functions, did a lot of stuff with rational functions. There was proper rational functions and improper, and we had asymptotes and all that stuff. So now we're solving rational equations. It really is not as involved as all the work with graphing the rational functions. So first of all, a rational equation, just like a rational function, is an equation that consists or contains at least one rational expression, or it has a variable in the denominator. Really, the idea to solve this, having a variable in the denominator is what causes problems. So what we can do, we find the least common multiple of the denominator, or really the least common denominator, and multiply both sides by that number, or it actually will be more of a polynomial or a binomial or something like that. That will then clear the fractions, and then it will be like solving a polynomial equation once you have that done. Make sure at the beginning you realize what your answers cannot be. Remember, your denominator cannot be 0. So any values of the variable, usually x, that make the denominator 0 cannot be one of your solutions. So once you find your solutions, just double check to make sure it doesn't make the denominator 0. Let's go ahead and move forward with our first example. Here we have a rational function, a rational equation I should say, and we have an n minus 5 in the denominator and an n minus 4. And so what I mentioned before, to make this an easier looking problem, easier to work with, is you can multiply both sides by the least common denominator. In this case, that would be n minus 5 and n minus 4. That's what you would need in the denominator. That would be our common denominator. So that's what we're going to multiply both sides by. So go ahead and write that out. So when we multiply here, multiplying this times this term here, the n minus 5s will cancel. Multiplying on the right side, the n minus 4s will cancel. So what we're left with, we can multiply this out. 3n times n is 3n squared. 3n times 4 is negative 12n. Multiplying here, multiply this out. 3n squared minus 15n plus n gives us that negative 14n, and then 1 times negative 5 is negative 5. Now to solve this, it's going to be easiest to have everything on the same side. So we want to really set the equation equal to 0. So we're going to subtract everything from this side. Subtract 3n squared, add 14n, and add 5. So doing that, subtracting 3n squared from both sides, that will eliminate this. Add 14n to both sides. Negative 12n plus 14n will just be 14n, and in fact I didn't set it equal to 0 because I realized we would just have a 2n over there, so it's equal to negative 5. Divide by 2, and you get your solution. Negative 5 over 2. Make sure you go back and check. Will negative 5 2 make sense, or really is it okay to have negative 5 halves, which is negative 2.5? By looking at this original, we couldn't have an answer of 5 because 5 would make the denominator 0, and we can't have an answer of 4, which would make the denominator 0. So n equals negative 5 halves is okay. You can write it as negative 5 halves, or you could write negative 2.5. The next example has more terms to it. The idea remains the same. We want to multiply both sides by the least common denominator, or we could say the least common multiple of the denominators. Well, x plus 3 is good, x minus 2 is fine here. We have a quadratic, which it would be helpful to factor that so we know what we're working with as factors of our denominator so we can find our least common denominator. So here we are with the original. We're going to factor the denominator, that middle one specifically, the other two are fine. And it factors to, in fact, it factors to x plus 3 times x minus 2. So x plus 3, this had x plus 3 times x minus 2, and this had x minus 2. So it doesn't always work out like this, but the factored part ends up being our least common multiple. Sometimes you'll have another term that has another factor, but here our least common multiple is x plus 3 times x minus 2, which realize we can't have an answer of 2 or negative 3 because that would make our one of the denominators 0. We can't have a denominator of 0 because we can't divide by 0. So we're going to multiply both sides of our equation by that least common multiple. Multiplying the right side is easy because 0 times anything is 0. When we multiply the left side here, we're going to take this, and we have 3 terms here. So we have to use our distributive property and multiply it times each term. So when we multiply it times this term, the x plus 3 would cancel, and we would be left with x minus 2 times 2x minus 1. Multiplying this times this term, if we remember, this factored is written here. It's x plus 3 times x minus 2, so both of these would cancel, and we'd just be left with 1. And then finally, we would multiply this and distribute it over here. What would cancel here? You would see the x minus 2 would cancel, and you would be left with x plus 3 times the numerator x minus 4. So that's what you'll see here in this next step. I multiplied times this term, the x plus 3 canceled, so we were left with x minus 2 times 2x minus 1. Multiply it times the second term. This whole thing canceled with the denominator. They were 1. Accidentally hit the screen, so there's the next line. And multiplying here, the x minus 2 cancels, and you're left with that. Now simplifying this, you can multiply this out, which gives you this 2x squared minus 5x plus 2. Still have our plus 1 here. Multiply this side out, or this part out, x squared minus x minus 12. Combine any like terms that we have here. We have a 2x squared plus x squared is 3x squared. Negative 5x minus x gives us this negative 6x. 2 plus 1 minus 12 gives us that negative 9. As you look at this equation, hopefully you notice we have 3 coefficients that are factors of 3. So go ahead and divide both sides by 3. And then we can factor this into x minus 3 times x plus 1. So x minus 3 times x plus 1 equals 0. So either x equals 3, that would make this 0, or x equals negative 1, which would make this 0. Checking back to our original, is it okay to have 3 and negative 1 as an answer? Yeah, the only ones that were excluded were 2 and negative 3. We have positive 3 and negative 1. So that is our solution. And that is rational equations. Key is factor denominators if necessary, multiply both sides by the least common denominator, and then simplify. Please use the rest of the time wisely to work on your homework. Enjoy the rest of your day.